Hey guys, so today we're going to go over multiplying polynomials, and what you want to do for this, you want to make sure that when you're multiplying the polynomials, for terms that have the same base variable, and I'll emphasize what that is, you want to make sure you're changing the exponent accordingly. So let's start off with number 1. It says, what is the product of 2r squared minus 5 and 3r? So I'm going to write this out as an actual product. So 2r squared minus 5 and then times 3r. So here we're going to end up doing simple distribution. So 3r times 2r squared. So r is what we call the base. Alright, that variable is called our base, and because they have the same base, we're going to actually end up changing the exponent. So this has an exponent of 2, this has an exponent of 1, you're going to add those two. So 2 times 3 gives you 6, but r squared times r gives you r to the third. Okay, let's do the next one. Minus, they don't have any variable in common, so you're just going to multiply the numbers. So it's going to be minus 5 times 3, which is 15r. That will be your expression. Let's move on to the next one. Simplify. X minus 6 quantity squared. You can just expand this as x minus 6 times x minus 6. So I'm actually going to use the box method. It's actually up and coming now with the Common Core method. So let's say I want to use the box method to solve this. So I have 2 terms here and 2 terms here. So I'm going to make a 4x4 box pretty much the best I can. So I have x minus 6 here, x minus 6 here, x times x is x squared. Negative 6 times negative 6, negative 6 times x is just negative 6x, x times negative 6 is again negative 6x, and then negative 6 times negative 6 is positive 36. Alright, so with the box method you can kind of add diagonally, so there's nothing with the x squared, so it's just x squared. And you add these, negative 6x plus negative 6x, that's negative 12x, and then we have 36 by itself, so that's plus 36. And that's the box method. You could have also used FOIL and distributed accordingly, but I'm not going to show that here. Alright, last but not least is when you have multivariable terms, you definitely want to pay attention to how the variables are changing, especially since there's a lot going on. So let's start off with distributing this term to the 4my. So we have 3 times 4, that's going to be 12. See, m cubed times m, that's m to the 4th. Y squared times y, that's y cubed. Okay, good. Now plus 3m cubed y squared multiplied by this. So that's going to be 3 times 10, that's 30. M cubed times nothing here, that's just m cubed. And then y squared times y squared, that's y to the 4th. And that's pretty much it. It looks like you can combine these terms, but you can't. This is m to the 4th, m to the 3rd, y cubed, y to the 4th. So even though they have the same base variable, they don't have the same exponent. And if they don't have the same exponent, then they are not like terms. But that's pretty much it. Of course, these can definitely get harder, especially with fractions and whatnot. But we'll definitely go over those later on in a different video. So if you have any questions, leave them in the comment section below, like and subscribe, and I'll make another video later. Bye guys!